Hello, everyone. I hope you can hear me well. Maybe someone can confirm.
Yeah, I can hear you fine.
Yes. Hi, Alexander.
Good day. How are you doing?
Fine. It's really nice to have you with us today.
Yeah, I really appreciate. Thank you for having me.
Yes,
Looking forward to this.
Thank you for accepting our invitation.
Absolutely.
So everyone, we are very happy to have you with us. This is the third Pioneer AI event to be hosted by IEEE Future University in Egypt student branch. Today we'll discuss a very important topic. We'll discuss mainly AI, some trends in AI, how to become a good, successful engineer in AI. But first, we'll play a greeting video from Andrew Ng, the founder of DeepLearning.ai. So we can start. Share our screen, video. Okay.
Hello, deep learners. I'm Andrew Ng, founder of DeepLearning.ai, and I'm excited to welcome you to our global deep learning community. I know that many of you are here today because you want to break into AI and build your career. I hope that being part of this community will help you to do so. To give you a proper welcome, I'd like to show you around the DeepLearning.ai offices and meet some of the teams so that you can see where it all happens.
Oh, hi, Andrew.
Do you want to tell our friends at Pioneer AI what you do at DeepLearning.ai?
Sure. Hi, everyone. I make articles and other media that help people learn about AI and help them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed.
What's been the most surprising thing you've run into working on The Batch?
How much is going on in this field? There's never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together every week.
All right, I know you're really busy, so I'll let you get back to it.
Thanks. See you later.
Let's go meet Kian, who helped me create the deep learning specialization. He's working on an exciting new project. Hey Kian, so do you want to tell the people at Pioneer AI what you're working on?
Yes, sure. I'm leading a project called Gontcharov, focusing on helping people get offers in AI and navigating their career by testing their skills, preparing for interviews and certifying them, as well as matching and referring them to good jobs in AI.
That's really cool. And what's the most exciting part of your day?
The AI is new. Organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist in the field, what tasks they will work on, and what skills are needed to achieve those tasks.
Yep, and that's really important work. Well, it's nice chatting. And now let's go chat with Hotel, who is on their product team.
Hey, Andrew.
Do you want to say hi to our friends at Pioneer AI and let them know what you're working on?
I would love to. Hi, everyone. I lead the product team in DeepLearning.ai, where we create AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks, Hotel.
Thanks, Andrew.
So, as you can see, our team is working hard to support you and help you learn. It's never been easier than before to break into AI. So if you want to build a career, you can leverage online resources available, including open source code, datasets, papers, and online courses like a deep learning specialization on Coursera. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving in to build your own project, or go ahead and try to replicate a research paper that you're excited about. One thing that I've seen help a lot of people succeed is if you can build a community or find a community of fellow deep learners you can meet with and study with on a regular basis. In fact, I hope that this Pine AI meetup that you're at right now will be a good place for you to meet these people. I hope you enjoyed the event today and that you learn a lot both from the talks and from each other. And once again, welcome to the DeepLearning.ai community.
Just as Andrew was saying, welcome to the DeepLearning.ai community. Today we have, as we said, our speaker for the day will be Aleksandr. Aleksandr currently works as a software engineer at Microsoft. He has a background in mathematics, and he worked on NLP research. So Aleksandr, I think you can share your screen now, and let's start this exciting event.
That sounds good. I'm just going to turn on my camera for a second just to say hi to everyone. So thank you for coming. Nice to meet everybody. Can everybody see me?
Yeah, we can see you.
Okay, great. So yeah, I was just listening to Andrew In, and he's totally right. It's never been easier to break into AI, and it's definitely with the deep learning specialization, you get enough skills that you can replicate state-of-the-art papers. And it just reminded me about 3 years ago, I replicated a state-of-the-art machine translation paper that can translate languages from one language to another just by reading the paper and coding it step by step. So it is very, very possible. And if you do that and just share it with the world so I created my own website where you can just post articles on LinkedIn, and just even if you just show screenshots of what you're doing, that will be a very, very good thing for just putting your name out there. And I think not enough people do that. I hope that everybody is excited about some great AI stories. I really appreciate everybody coming because I've been there where you are, and I wish at that point I had more information about the field, industry, and so on. And as much as you can learn a lot of things from courses, a lot of things I'm going to talk about today are, sort of a lot of the hard lessons you learn from industry once you're in it, about the reality that it's not so sugar coated sometimes as even Andrew In makes it out to be. I just want to ask a quick question. Everybody who is at the university there, are you undergraduate students, graduate students? I just want to get a feel for like who our audiences.
I think we have many university students from Future University, including me.
Are they, is it like a bachelor's degree, master's degree, PhD students, or just everybody?
Yeah, I guess I think most of the audience are undergraduates.
Okay, yeah, that's good to hear. Okay, awesome. So I'm gonna share my screen and I'll get started. Let's see, screen 3. I prepared some slides here so we can talk. All right, can everybody see that?
Yes, we can see.
And is my video still visible?
Yes, we can see you.
Okay, yeah, there you go. All right, I might as well keep the video on then.
Awesome.
Okay, great. Okay, so first I'm going to just introduce myself, talk a little bit about my background, kind of how I got into AI, because my background is actually in mathematics. I was living in Canada since I was 10 years old. I was born in Russia, And I went to University of Toronto to do my undergraduate in mathematics. And then I went to do I went to University of Ottawa, which is the capital city in Canada, and I studied a master's in mathematics. This is before I even knew anything about AI or had even had any interest in it. But the thing that I did for my dissertation was a thesis on a field in math called Lie algebras. And for the lay person, this is the study of matrices, like in linear algebra in math, except at the level of Lie algebras, I was studying infinite sized matrices. So if you can imagine an array that goes into infinite directions up and down, and you know, you can take those as objects and multiply them together and things like that. And I did a thesis on studying the properties of those. After I graduated, I did a few years in industry, working several jobs in various fields, such as nonprofit organizations, banking, government. And I was just doing kind of regular data, which you would maybe call a data analyst, things like that. They didn't really have the term data scientist really almost like 10 years ago. It only came into existence in the last like 5 years or so. But I guess in some sense, you could have called me a data scientist because that's just such a generic term nowadays. But eventually, I wasn't really that challenged by the things that I was doing in my career. So I kept hearing about artificial intelligence, and I decided to check it out. And in the evenings after my job, I started to study some things, and I came across the machine learning specialization. And that really was the thing that launched my career. And I'll tell you a story a little bit later about how I found my first job in the AI, because I had already had some experience there. And the first job I found was a startup company in Canada that was specializing in artificial intelligence. When I joined that company, within 6 months, I published a paper on in natural language processing, where we were classifying essentially we were classifying sentences that you could read in a research paper in the medical field. It was very interesting, and we were able to just combine a couple of models together and create a really good data set. So we really just did fundamentals. We cleaned the data set a lot better, and we just applied some common sense to create a model, and we trained it on the cloud. And using that, we were able to get a state-of-the-art result. And this paper was presented in Italy in a conference for one of the top world's organizations in natural language processing. And a few years later, because this is a startup, they took this paper and they turned it into a patent. So apparently this specific way to model sentences in medicine is now patented. And this is all just to hint for you later on. I'm going to talk about doing research in AI, and I kind of think that it's actually kind of easy. It sounds like probably a funny thing to say, but when I say it's easy compared to other sciences right now, because it's such a young field, there's actually a very, you could say, the standards are just not there yet. Like if you wanted to publish a paper in physics or math, I mean, the standards are just so high, you're going to have peer reviewers. So it's currently really not so. That's why this is really a great opportunity in terms of getting into this field. I also did some speaking, and I have a slide later. So during that time when I was working at the startup, I started to go to conferences, and I would speak on stage on AI and how to actually be practical about using it in your business and other topics. After I was working at the startup, I decided to become a independent consultant, where I was consulting at the highest level in Canada for government agencies, and those government agencies included some of the secret agencies. So I had to get a secret security clearance, and a lot of them are very interested in artificial intelligence, but they really don't have the knowledge that you guys would have, and they bring in consultants. Somebody with, at that point, I had had experience working internally in the government, then I was working at a startup. using some of the latest technology. So I was skilled enough to be able to help them. But based on the story I'm going to tell you a little bit later, I really wasn't satisfied with the type of work that we were doing. And I decided to just, okay, I need to go for like the top, who are the people who are the top companies who are doing AI research and facilitating other companies. And I applied to Google and Apple and Facebook, and I actually ended up getting a job at Microsoft, which is really great. It was a very difficult job to get. The way that they interview you is a very, very grueling process, but it's been actually one of the best decisions I've ever made in my life. And now I live in Seattle. This is my Seattle coffee cup, and I like it here. I've been here for about 6 months. So that's roughly my story and who I am. And now we're going to take a quick pause, take a breath. And oh yeah, one more thing. When I joined Microsoft, I pivoted a little bit away from just doing AI and data science, a little bit more towards software engineering. And I'm going to talk about that in a minute as well. And that has to do with the trends that I personally see in this industry. And also throughout this process, I've been doing some of my own neural network research on the side, where I created some visualizations. If you go to my website, which you can find the link on my LinkedIn profile, and everybody here is welcome to add me on LinkedIn as well, if you haven't already. And there's a link to my website where you can see some of my visualization tools that I, if anybody has ever used the TensorFlow playground, it's a tool for visualizing how small neural networks learn and the decision boundaries being drawn in real time. I created a 3-dimensional version of that because I think that there's more you can see by seeing the extra dimension, and it's something I want to pursue later on. And that's something else I'm going to talk about as well. So these are just some pictures of when I was speaking. So here on top, I was on a panel among people in the government of Canada, because I was one of the few people. See, it's such a new field. I really, you would think that somebody on a panel would be, somebody with decades of experience, but because it's such a new field, it's really just a great opportunity. If you go out there and you get a job in this field, and then you put your name out there by doing some talks, doing some presentations, like it doesn't take long for people to just see you as an expert. Actually, kind of find it funny that this talk was titled "Talk to an Expert in AI," because I don't consider myself an expert. But then at the same time, when I look at my experience, I think that, not a lot of other people have that. Here I was talking at the Public Health Agency of Canada on artificial intelligence. Then I also did some talks. We have these meetups, so I'm sure you guys have something too. So like just locally in your city, you can find people who organize independent presentations. So for example, there could be like a monthly meetup on software engineering or AI. And I think it's a great idea to just like create a presentation and just go up on stage and present, and because people are always looking for speakers. So I've done that as well. I created a talk on how to organize a machine learning project. And I was, and I did that with my colleague there. I also did a talk on demystifying AI and how to get started in machine learning. So similar to what I'm doing now, I did something called a lunch and learn, which is you go into some company and for free, you just, while they're having lunch during like the noon hour, you just give them a quick presentation on anything. So they're called lunch and learns. So this is just a sample. I was doing this a lot. And I think that speaking is a really, really great skill in communication that is not emphasized enough in this field. And I've always been really passionate about it. And I think that's one of the things that helped me to succeed, because if you just look my name up on Google, you often see like, I find it's funny, I find like this is something I spoke at in 2018, 2019. And think about the point of view of an employer. If you put your resume to a job, if you apply for a job and then they just look you up on Google, and that's the first thing they see, I think that will make you stand out as a candidate. Okay, so now I'm going to move on to the next section here. These are just some recommendations from my personal advice from me to you of how you can land an AI job and some of the things that you can do. And by the way, I'm not going to go into too much depth into any of this. That's why towards the end, I'm just going to try to finish this talk part quickly. And I want to have a lot of time for questions or just discussions. But as I'm talking, feel free to take some notes if you have a question so that you can ask it later. So the first thing I'm going to do is I'm going to recommend the things that you're going to learn. So learn AI, and that includes learn the math behind it. So in math, you should learn linear algebra, multivariable calculus, and probability. Those are the three basic fields that you would need to just understand at a high level, at a minimum, how a neural network works, how it trains, how other models work. And if you guys are interested, I can also recommend specific resources, books, courses for any of these topics as well, because this is where my field is at, math, and I can really definitely recommend some good resources there. The other thing I would recommend is everybody's always really excited about deep learning, but there are all these other models other than deep learning that everybody should know about. And you should just have a high level idea of what kind of data are you working with. Are you working with unstructured data, such as images, such as text, or are you working with structured data, picture like a table, like in Excel, with many, many rows and columns. So just from that alone, you can figure out which models are going to be more suitable. The size of your data set, the types of, is it a classification problem with one label, multi-label? All of that stuff should just come to your mind naturally with some experience. And having that breadth of knowledge as opposed to depth can really help you, because in industry, even though deep learning is really cool, the actual reality is that a lot of the data that people have isn't really amenable to deep learning, because it might just be easier to train a small, classification, like an old school classification algorithm, because deep learning wouldn't do much anyway. Maybe the data set isn't big enough. So having those tools in your tool belt is very, very useful. And actually, Andrew Ng's original machine learning course, so he has the machine learning specialization, but he has that older course that's just called machine learning. That one is a great introduction to a lot of those models that I'm talking about. Then the next thing I'm going to talk about is learn AI and data science related programming skills. So even though you can understand how a model works, and from my personal experience, I've seen a lot of people who come from a hard science background, like they studied chemistry, biology, physics. So they're very good in the science portion. They're very good in probability statistics, but they are just not as skilled and experienced in the tools. So they wouldn't know how to, program it in TensorFlow or scikit-learn. So, a lot of people use R instead of Python, and there's the kind of whole debate which one is better. I think you should just learn a little bit of everything, but I also believe that you should learn the tools that are most in demand. And from my experience, R is not as in demand in Python, depending on the field. R is used, and there's even other programming languages as well, but they're used in certain subfields a lot more. Get good with libraries such as TensorFlow, PyTorch, scikit-learn, and so on. And then the third thing is learn software engineering. So this is since I joined Microsoft, I've been focusing on just learning software engineering. So you could say that those first two categories were already my strengths. So software engineering, I guess a lot of you are already in university for that. So that's great because the thing that you would want to really learn for industry is cloud computing. So in cloud computing, we have AWS and Azure and GCP, which is Google Cloud Platform. Those three are I think they're the biggest three vendors of cloud. I think there's another one I'm probably missing. And all of them have free trials. So you can use a lot of their things for free. So just like learn how to train a model on the cloud, learn how to train a model with distributed GPUs, and all of the instructions and all of the step-by-step tutorials are on the websites for these for the documentation for these platforms. Because that's what you will be expected to do. And this is often what happens with somebody who, say, really is great at, and this is where I was really good at linear algebra and multivariable calculus, but then somebody just said, okay, now train a model and use the cloud. And I realized, oh, wow, like I'm missing all of these software engineering principles. But meanwhile, there are other people who are very good at that, but they wouldn't know the first thing about calculus. And as a result, I realized that once you learn the AI part, to bridge this gap is a lot easier than for other people who just have a purely computer science background, who never studied data science. It's much harder to pick up the math. And I just listed some other things that came off the top of my head. So everybody in this industry uses Git. You will be using Linux and Bash. So regardless of your opinion on any of these softwares or software tools, I always just study the things that are out there and they're in demand. And I try not to judge like, oh, I don't like this tool. Like, I don't like to have an opinion necessarily about which tool is good or bad. I think that if I just learn several tools, at that point, you can form an opinion. But at the same time, if you join a company and they tell you to use this tool, but you happen to not like it, it's not like you have really a choice. So it's really just a matter of just get good at everything. That's my advice. And the third thing is to get a job such as the one I got in Microsoft, learn about data structures and algorithms. In other words, learn how to do programming interview questions. And I will mention a little bit about what I do at Microsoft. Microsoft releases APIs for different machine learning services. So for example, if you wanted to do a speech to text, you don't have to train your own model. You just type some text and you send a request in an API, and it will return back to you the sound of the person saying the words. So there will be like a text to speech. They also have the same thing for say image classification. So you can send an image and they will tell you which category it belongs to and so on. So these APIs are maintained in the cloud. And I work in the department of Microsoft called Cloud and AI. And I specifically work on helping these all of these services stay online. So I don't deal with the models directly, but these models are deployed in the cloud in containers in Kubernetes. And I will go in and ensure that they are online and they are serving the customers. After a few years of doing that, I do want to get back a little bit more into the artificial intelligence, more of the actual research, maybe science side. But the way I see it now is, and I will probably mention this a little bit later, is I think that the software engineering skills go a long way in keeping you employable in the future in this field. And I'm going to talk a little bit more about that. Okay, now I'm going to talk about research in AI. So I mentioned earlier that there's a paper that I published. I guess I can quickly click on it and show you what it looks like. So this is the paper that I wrote. As you can see, it has that familiar look to it of archive.org. So everybody here should be familiar with this website here, archive.org. It's spelled like with an X here. And in this paper, we discuss natural language processing. So if you actually read the paper, you'll notice that it's actually nothing too complicated in here. And it's pretty short, and anybody can do this. This was just written by me and 2 colleagues, and we just split up the sections. I was I mainly wrote the part about a data set, and he designed the model and trained it. And we just read about 10 to 12 papers in this field from before, which gave us enough information to write a really good abstract and background section to explain why we're training these models. So I think that I guess I'm just showing you this to, you know, to motivate you, just to say that I think that anyone can write a paper. It's really not difficult. It's just something you have to do, and in the kind of, there's nothing holding you back from writing it, and just being able to submit it to a bunch of journals. And that's what we did. And I was actually honestly surprised that anybody accepted a paper that we wrote, because like, we weren't that experienced. But that's the thing, is that in this field, it's so new that if you do a good job and if you have passion for what you do, it's really not surprising that other people, because you will stand out. So the next thing that's important in research, and this is just a general skill for machine learning, is learn the skill of evaluating models. So here's what I mean by that. A lot of people get so excited about the idea of, you know, you take a giant data set and you train it with a 50-layer neural network, and it predicts 1 or 2 things correctly, and you just get so excited. And that is exciting. But how do you scientifically test that it's better than other models? So you have to get really good at all the different metrics and choose them early on. So some of the metrics for classification that I got good at from experience would be precision and recall, because everybody talks about the accuracy of a model, but actually precision and recall are often a little bit more useful depending on the task. And so that is just a general skill as well that should be on your list to learn, but it's extremely important, if not fundamental, for research. Another one is choose a niche. And what I mean by a niche is choose a very specific subfield, like we chose in this case, medicine. And in medicine, there's a very specific procedure that they use to evaluate papers, where they look at the population of the clinical trial. They look at the intervention that was given to the population, such as if they were given, you know, some kind of prescription to take, or they were prescribed exercise, and the outcome, which was like, you know, was this helpful to, you know, reduce their symptoms? And because that's such a niche topic, we created a model that can automatically predict a population, an intervention, and an outcome just by being able to scan a paper. And what is the benefit of this? It saved people time, because a researcher has to read the whole paper just to find that basic information, but an AI model can help you find that information faster. So because it was such a niche, you are actually reducing the number of, you know, potential competition that you have. The other option you have is to go really general. I think you'll probably have more success if you do a niche in terms of being recognized, but I personally like to go general. So the stuff that I was mentioned earlier about my neural network visualization is that is a very general research. I'm just visualizing what a neural network does, how it works, and what I want to do with that is actually improve some fundamentals of neural networks, such as initialization techniques, such as the optimization algorithm. Like, you guys might have heard of the Atom optimizer. Like, I think there is stuff to make those optimizers better, for example, because that's such a general technique. I think it has more of a potential to really influence everything, because if you create a better optimizer, it can be applied to any neural network. Whereas a niche just means that you created a specific model for that field. and it's not really going to be able to be generalized. I guess just coming from a math background, I like things to be generalizable. Another one is submit it to the right journals. So once you do it, don't be afraid to just write to everybody, submit journals. They always have very specific criteria. They have a deadline, they have a specific format. Just adhere to that, and that's my advice. So I think if you are interested in doing research, that's something that is possible, and it's not that difficult. It's just a matter of just do it, or if that's something that you want to do. And the last one is present everywhere. So just you can write a paper, and even if no journal accepts it, nobody looks at it, go to a local meetup and just say, I want to present to you what my research is about. Go to a local university, you know, and do, like, if there's a student club or something, just present it there. And keep track of all those presentations and add them to your LinkedIn, add them to your resume, because it all looks really good. And potential employers will really see that that is really valuable, because it shows them that you have passion, that you have excitement for the field, and that you care. Now I want to talk about a little bit of the more cynical side of this field. So I want to tell you a story about how I first tried to get my job in industry in artificial intelligence. So at the time I was working in the government, and the government really isn't doing much in AI, but I looked at some jobs outside of the government, because that's where a lot of more of the innovation happens. And here's what I found. So I'm going to tell you about my adventures looking for that elusive AI opportunity, and what kinds of conversations I had with potential AI employers. So the first thing that you guys should know is that anybody that you're going to talk with who is in this field, it's hard to find resources. So everybody who is learning something in this field, who's learning deep neural networks, etc., most people are self-taught. There are some university programs, like you guys are probably doing some data science courses, I assume, but that's rare. So you guys are really the exception to the rule. And everybody you find in industry learn things by going on Google, reading a blog, etc. So it's very difficult to find good resources. So because it's hard to find good resources and everybody is self-taught, it really takes a lot of motivation and personal perseverance to just learn and to get into this field. And that already makes you stand out. So yeah, like I said, you have to seek out books online, and you have to be able to figure out which ones are the good resources and so on. You have to learn all these tools like Python, TensorFlow, and how they interact with GPUs. So there's a lot of skills that you bring to the table. I searched for opportunities. So I looked at job postings, and here's what you're going to do. You know, you might look at job descriptions that are hiring, and they're going to say, we're looking for somebody who does machine learning, who does AI. We want somebody who knows Python, who knows TensorFlow, and some are very, very specific. So because they're very specific, when you read a job posting like that, you might think, oh, wow, this company must be really doing some great things with artificial intelligence. You might think maybe they have a team, maybe they have all the tools, maybe they have a plan of what they want to do, and maybe they are already doing something with AI and they just want to hire you to help them contribute. And what I found is that I went to job interviews and they would say, oh, nobody in our team knows Python. Nobody in their team knows anything about AI. We just want to hire you so that you can give us some advice on far, far down the road what we might do. Nothing was actually happening, and they just had some ideas about the future. And I kind of realized, well, how did this person know that much about AI? And I realized after talking to that person that whoever was interviewing me, that they themselves just learned by reading a couple of blogs, because they themselves were not programmers or anything like that, or even if they were, it was just like a personal hobby. So going to a job like that, you're going to be the only one in the whole company who knows things about AI, who knows things about machine learning, and it will be impossible to get anything done. And that is actually, believe it or not, the norm in a lot of companies, because it's such an exciting field. Everybody wants to have a piece of it, but a lot of those opportunities, it's up to you to be able to figure out if it's that kind of opportunity or if it's a real opportunity. And this is the reason why I went to a company like Microsoft, because you know for sure that if you're looking for something in a company like that, or in Google, or in a company that's known for other tech, you will know that they will have experts. And the first thing that you want to do is you want to go to a company where you can learn from mentors and other people who know how to do it. You don't want to feel like, well, all I did was I just finished engineering specialization, and now I'm an expert. Like, I don't think it works that way, but that's actually kind of how it works. The other thing that I did was I attended AI conferences during this time, and I met people in industry who had AI as part of their job title. So for example, I would meet somebody who's like, oh, I'm an AI manager in this bank. Those people, one guy in particular, like I would be very excited. I'm like, oh, that maybe I actually found a job in AI that's out there. I figured out like, well, what's going on? What do you guys do with AI? What kind of techniques do you use? Do you guys use TensorFlow? Do you use deep learning? Do you use classification algorithm? And then after talking to him for a minute, I realized, well, they actually outsourced all that stuff to some other company, and that other company used a point and click tool. So there was really nothing exciting going on once again. So I kind of realized it's going to be a little bit harder to find a good job in AI where I was living. Another thing is that many companies may have challenges in developing AI internally. So this is what I found, is that unless it's already a company that knows how to do software engineering, knows how to do science, a lot of these companies are just like a bank. Like, what is a bank good at? They're good at, doing banking and opening checking accounts and loans. They're not a tech company. Like, sure, they have a website and they have security, but they want to develop AI internally. They often don't have the tools. They often don't have Python and all of these tools. And a lot of them, the big companies, they won't even allow you to install things like that. So this is something that you guys might not realize if you've never worked in a big company or in any company, is that a lot of times you can, when you go to a job, it doesn't allow you to install anything. You can't just like randomly go online and install a piece of software. So if you need an actual tool, such as, a programming language or a library, you can't just install it. And then to be able to install it, somebody up higher in the chain has to approve it. And that approval takes 6 months. And oftentimes they just like don't see the feasibility, they don't see the reason why you need it. So that's just some part of the reality of the industry as well. Yeah, had to pre-approve that the tools are safe. Another thing that you'll notice is that these companies oftentimes don't have a real problem to solve. So they'll say like, oh, we just want to use AI, but they don't have like a particular, they just think it's cool and they want to use it. And a lot of it is PR. They want to be able to go to a conference. Like the bank wants to go to a conference and say, we're using AI, but that's the only reason. It doesn't mean that AI was a good idea to use. Yeah, they want to use it as a tool, but they don't have a problem suited to AI. So they start with the solution method as opposed to the problem. See, normally the way it works is you have a problem and you look at all the ways you could solve it, and maybe AI is the right way to do it. They start with AI and then they find the problem. That is a backwards way of thinking. And many companies are not set up currently to attract, train, and retain top talent. They have to have the knowledge and the training in-house, and that's not currently available. So for that reason, like they have trouble really hanging on to it. And it's hard to retain talent because if you take a really, really big company, it's a split environment. So there is no central AI hub in this company where you will work with other experts and they will serve as clients, the other parts of the company. What they do is like they will hire like one person in AI in the HR department, another person in AI in like, I don't know, the finance department. And those people don't work together. And all of that stuff just means at the end of the day, like you're not going to be producing much. So this is actually just the story of what happened with me. And now I'm going to talk to you about some tips so that you can do things in a smart way. So the first thing you want to do is you want to look for opportunities that fit your skills and your goals. So many companies will claim that they do cutting edge AI, but it may not be what you expected. So imagine that this is the reality of what I told you. Based on that, it's up to you, even though you're the one looking for the job, you have to ask them questions that only somebody who did AI would know the answers to. Because at first it might seem like, oh, they're this great company that are doing all this AI. But let's say you ask them, how do you evaluate your models? If they answer that directly, that means that they already have models trained. But if they start to kind of say, oh, like, well, we still have to figure out which models we train, it probably just tells you that they're really not doing much. So in a way, keep in mind that because this field is so popular right now, you really have the choice more than the employer. So you're also interviewing them and you want the job that's really exciting for you, where you will be able to utilize your skills. Ensure that they have other people on the team who have the skills that you are bringing. So I'm just emphasizing that one more time. You want to make sure that they have a team of other people who are doing this so you can learn. And lastly, I'm going to say, so I mentioned earlier that I was doing my own AI research sometimes, and I created these visualizers, and these are just personal projects that I did. You guys might be super, super excited about deep learning, AI, machine learning, and so on. And the mistake would be that you will go to a job where you will do exactly what you want to do and you will be super satisfied and you will kind of feed that curiosity and satisfaction you have with AI. Chances are you're going to find a job where you will be using some good skills and it will help you make money and pay bills. But if you really have a deeper appreciation and passion for AI, if that happens to be satisfied in a job setting, then you've won the lottery. That's exactly what you want. However, to me, like, just do personal projects at home to satisfy that curiosity, and then find a job that's practical, where you can make a good salary, where you can enjoy, where you can have good colleagues, you can have a good boss, you enjoy going there, and you're working on interesting problems, but not necessarily going to be like your passion. I think that is a more realistic approach of what can happen. I'm actually going to show you very quickly my my website, where you can see where I'm going to quickly show you. I made this about a year ago. This actually helped me get a job in Microsoft, because when they interviewed me, they said that they liked what I did here. So you choose a different data sets here, and you create a basic neural network. So here we have 16 hidden neurons and 16 more hidden neurons, and I'm going to train the model. So this trains a TensorFlow model, and it caches at every epoch. It actually caches all of the weights, and then what you can do is you can actually see. So this is interactive. What you can do is you can see exactly how the neural network trained from a 3-dimensional level, and here's how it goes. Is everybody ready? So there you go, and you can move it around. You can see what it looks like. You can zoom in. There's a loss and an accuracy there. So this required some knowledge of mathematics and all of that to really, because I programmed this from scratch. So this was just a personal project. So that's another thing I encourage everybody to do. Do personal projects and put them online. Like, this is online, anybody can see it. This is very cool to do. I'm going to go to the next part now. So I'm almost done. This is my last slide. I'm going to talk a little bit about the trends that I see in this industry. The trend that I see is that about three years ago, around 2017, 2018, there was a little bit more emphasis on building your own custom model. So you would actually have when you go to a job, you would actually program, layer 1, layer 2, layer 3, and you would create the architecture, you would train it, you would get your own data set and so on. It's a little bit of a research. You're actually doing more data science. I found that over the last few years, people train models, pre-package them, and people just download and use the models, because the idea is that people have done so well in doing that that there's really not a very high chance that you will train a model just by importing TensorFlow in your Python script and just training it that will be better than the models that are out there. And so because of that, people will download a model, they will put it into an application, into an architecture, and they will deploy it on the cloud in Docker. So that implementation, in my opinion, it's still AI, but you're not actually doing necessarily like data science. You're not evaluating the model and so on. So I think that that implementation is a little bit more of a trend. And that is why I saw this firsthand, because the real skills that I looked at a lot of job posting over many years, and initially it was like, can you train a model in TensorFlow? And then it trended towards, can you build a Kubernetes cluster and put a container on it? The container supposedly could have a model in there. Can you then create it so that it's an API that will be able to query the model through REST? And for that reason, I saw that and I realized, well, you know what, if this trend keeps going, this is my own personal opinion, if this trend keeps going, maybe 5 years from now, you will essentially not need to ever train anything. You're just going to take models off the shelf. That means that the real skill is, can you implement it and put it in the production mode? So for that reason, I kind of said, well, that's why it's a good idea to learn more software engineering skills, because I'm not sure that just doing pure training of models will really be as valuable 10 years from now. That's just what I think. That's why I believe you should diversify your skills, like I mentioned earlier. Another thing is there's AI and deep learning research versus engineering. So I guess a lot of you are in software engineering. So you have to ask yourself, because there's no like one AI job or data science job. There's jobs where you can answer different kinds of questions. So in research, the kinds of questions that you're going to answer are, how can I improve the accuracy that this model predicts this category? And that means you have to go into like deep into the layers and figure out the math, retrain the models, question the hypotheses, etc. But engineering would be kind of like, we have a data stream of millions of images per second. How do I ensure that the throughput of those images into this API is always going to predict? So you guys know, like when you're using Google Maps or when you're using Google Photos, that's constantly what's going on. There's like these high throughput, low latency APIs, and that's part of the engineering behind AI. Specialize in one of those, like learn a little bit of everything, but at that point, like figure out that maybe the job title for that would be machine learning engineer, data engineer, but then for the other one would be like data scientist, machine learning scientist, and so on. So those job titles correspond to the fields that to the type of work you'll be doing. Another one is, don't be afraid to try many different industries and positions. So this is a very, very, this field is hiring a lot. So if you work for, you could be working for a pharmaceutical company in AI, and then you could be working for an oil company in AI, then you could be working for a bank, then you could be working for a software company, then you could be working for a research company. Definitely try all different things, because the field is hiring a lot. And different fields will have different trends in what they're doing. Like, for example, I found that more medical fields, the people that are in that field, they are already more science-based backgrounds. So they will have people who have like a, medicine, like an MD. They will have PhDs in psychology. So those people are going to be a little bit less about like the software engineering side of things. And they're going to want to talk to you about is like, oh, like what's the statistical probability of your model? But then you go to a company like Microsoft where I work now, and people don't have that background. They're just like software engineers, and they're just talking to me about the syntax of my code all the time. So it depends which field fits you more. So just try a lot of stuff. Another one is don't be afraid to shoot for the top. You know, like I was living in Canada and I tried, you know, all these different startups and industries and all these things. And then one day I said, you know, I'm just going to try to go for like Microsoft or Google. And I just applied, and lo and behold, like it didn't take that long for them to just give me an interview. So don't be afraid to do that, because the field, I believe that this is a unique opportunity today, in that because of the pandemic, people are using AI software so much, but at the same time, the pandemic has made people more conservative. Like they're a little bit scared to move because maybe there's going to be another outbreak. And it's like the demand is high and it's difficult for them to find good software engineers. So as long as you have any kind of things on your resume, I believe that it's possible, might as well just shoot for the top. So that's my other advice. And with that, we come to an end. Thank you, everyone, for listening. I'll let Abdallah take over and let me know if how we're gonna conduct the questions, or we're just gonna take questions.
Yes, thank you, Aleksandr, so much for this entertaining talk. I think these are such important tips for getting an AI job. So everyone, you can send your questions on the chat, and then we can have a discussion with Aleksandr. I myself have some questions for you. Maybe we can discuss them.
Absolutely.
You mentioned in the beginning that it's important to know mathematics. Can we discuss this furthermore? Like, how much mathematics do you really need? Like, when you study something like support vector machines, how it originated, you see a lot of mathematics. So do we really need to know all of this or understand this so we can implement these algorithms?
That's a great question. I would say that it depends on what kind of job you are doing. So as I mentioned earlier, if you are working in just say like more the machine learning engineering side, like you might not be that concerned about exactly the math behind it, because a lot of what I find personally is a lot of people who come from a computer science background, they just want to see the model as a function. Like everybody knows how to do, like, you know, a function in a programming language. You know, you give it an x and y and it returns x times y. And they don't care about the implementation. So they see a model as just a function. You put in an image and it gives you a percentage. But the idea is that I'm a little bit biased towards learning the math. I think that it's important at a minimum to learn how it works. Even if you forget it a month later, if you can understand it, it's a little bit like, you know, it's a rite of passage for you to know how it works, how it trained. And in order to do that, you need to know some minimal amount of usually like some calculus, linear algebra, and things like that. So I believe you can get away with just learning, like, you know, the first year university equivalent of calculus, probability, linear algebra, and that will be enough for you. Even if you skip some detail here and there, if you can understand at a high level, yes, this, you know, updates the weights in this way, and here's how it works. I think that that's personally very important. That's at a minimum. But if you are, you know, talented in math, if you go at a higher level, there's nothing stopping you from being able to understand it better. And the way you can test yourself, if you actually understand how any of these models work, is try to program it from scratch. Try to see if you can, don't use TensorFlow, just use regular programming languages and see if you can just do a bunch of loops, update a bunch of, you know, weight. And if you do that and it works, At that point, you should not use that code because it's not going to be very efficient. I'll compare it like this, like on a calculator, we have a button that says like square root, but you shouldn't think of it as like a magic button. You should actually understand what a square root is. And in the calculator, there's some algorithm that it uses to calculate the square root. Do it once in your life where you figure out how square root is calculated. And then after that, never use your own calculation, but just use the button. That's how I see TensorFlow and all these tools. They are designed to be very efficient computationally, but you shouldn't rely on your own implementation. But if the fact that you implemented it, and that's Andrew Ng's specialization gets you to actually do that in a lot of the exercises, which is why it's so valuable. So that's does that answer your question?
Yeah, I think this is that really answers my question. So for learning some more about mathematics, you mentioned that you have interesting resources. So can you share this with us?
Oh yes, absolutely. So for linear, I'm just going to write them down as I'm typing. So for linear algebra, there is a course by Gilbert Strang. I believe it's from 2005, and the lectures are on YouTube, and I think it's just called linear algebra. So for that one, that is just a really, really excellent introduction for linear algebra. For calculus and multivariable calculus, I would recommend there's a website called The Great Courses. And this is a website where you can actually do a subscription similar to Netflix, but you can buy the courses individually, and it's not very expensive. But what they do is they hire the best university professors in the world, and they get them to do like very, very high quality and very, very informative and passionate lectures. Anything in that website, actually, for anything I would recommend. But they have really good course on calculus that if you're really not math inclined and you just want to know the essence of what's calculus about, like that, some of those there's a course in there called calculus. I think it's called Change in Motion, Calculus Made Clear. And in that course, he explains how calculus works. And in the first lecture, he just has a toy car, and he rides the toy car on the table, and he explains the difference between a derivative and an integral. And it's very, very, very well done. Let's just say that. So that's for that. For probability, I don't really have any specific recommendation for that. But I would recommend this book called, do I have it on there? No, I don't have it next to me. It's called, there's a book called Deep Learning with Python by Francois Chollet. This book is actually how to program TensorFlow with Python and deep learning. And the book is written by the guy who created TensorFlow. And it's a very, very good book. So this is, I'd say, one of my top recommendations outside of the deep learning specialization.
Great, thanks a lot for these resources. We have a question about MOOCs and boot camps, like online resources. I think a very important course like you took and a lot of people took and maybe changed their AI career is the deep learning specialization. And DeepLearning.ai have a lot of other courses that cover important aspects in AI, such as machine learning, engineering, production services, or something like that. Things that help you improve your TensorFlow skills. So what are your opinions on such courses?
I think that if you can find a course that is that you find enjoyable, that is the hardest part, because there's a lot of them now. If you go to YouTube, you can watch courses by the best universities in the world that are just recorded. I think I've done that a lot personally. I would really highly recommend to develop the skill of finding good resources to learn. And it's really a personal question of what helps you. And it could be a MOOC, I guess it's called MOOC, MOOC. It could be one of those. It could be a book. It could be like I don't know. I was just learning, for example, Rust, the programming language Rust. And even though I could learn it online, I just bought this book. It's getting blurry. It's called Programming. Here we go, Programming Rust. And I found this book to be better to learn that programming language than going online and doing some tutorial or watching a YouTube video or looking at a MOOC. So get good at the skill of finding good resources to learn. And I think they're all very, very valuable, because it will never stop. Like, you will always continue learning. And I'm happy with that. And I think that's what keeps you employed. That's what keeps you, highly paid and valuable as an employee. And it's just something that the field isn't for you if you don't like learning. As far as boot camps, the other question was about boot camps. I just don't have any experience with boot camps, but I do know that it has helped. Like, I have a colleague at Microsoft who just took a boot camp, and he didn't know software engineering before, and he got a job at Microsoft. So from what I understand, like, they can be very valuable.
Great. You mentioned programming languages. I've heard that Julia is now being used in AI and starting to have like some advantages over Python. So what are your opinions on this language, if you have used it or heard of it before? It's just something new.
Yeah, I have heard of it. I used to have a colleague at that startup who was all about programming in Julia. The way I see it is, I personally have not, but the way I see it is, you want to keep your finger on the pulse of the industry. You can go online and look up what are the top programming languages, and you will see that Python is actually up there for data science or just in general. But then you will see programming languages like Julia that will trend up, like that Rust programming language I just mentioned about, that is trending up now. So if you are somebody who doesn't do that, who doesn't look at the trends, you're going to learn some programming language, and 5-10 years from now, it will be in the top 50. It will be number 50. So whether it's Julia, whether it's Python, whether it's Rust, whether it's anything, learn the things that correspond to what your career is, because the fact is that it's hard to learn anything well. It's hard to learn Python well, it's hard to learn Rust well, it's hard to learn C++ well, or any programming language. So because we have that limited capacity, be intelligent in like choosing the right language, and then learn it and learn it well. Because if you're choosing anything in the top 5-10 programming languages, there will be opportunities for you. So that's how I strategize it. So to me, I never look at like, this language is better than another language. Like Rust, for example, I could talk to you about how that language is better than other languages because it has better memory safety and it's better for security. But at the end of the day, does that matter if nobody's hiring in that language? No. So
exactly.
That's just my general approach to it.
Yeah. Okay, so I have another question. If you have helpful courses to share with us to learn Python?
It's a great question.
And how far should we study Python? Like, should we take a lot of time improving our Python skills, or like learn the basics and then learn on the fly when you're learning TensorFlow or you're applying something? This is, I think this is an interesting question also.
I learned Python over so many years and I used so many resources. I don't know personally if one really stood out. But in any programming language, I'm just going to say this. in any programming language, there's almost like two things that you have to know. The first one is learn how to program in the programming language. Assume that somebody just gives you a window where you can type code and then execute that code or compile that code and see the answer. In that environment, you're not learning anything about how the language works in production. But what you are learning is you're learning like how do you do a like a for loop? How do you do a while loop? What kinds of variables are available to you? Things like that. So the basics of a programming language, you can learn Python, you can learn that anywhere. You can go on YouTube and just do like a crash course in Python. To me, that's only half of learning any language, because in industry, what happens is you will now have to do the following with Python. You're going to have to know, how do you install Python? How do you run Python in a Docker container? How do you SSH into that Docker container so you can like execute Python in it? How do you install packages? How do you do virtual environments in Python? This is just the tools behind Python, or the tools behind any of these programming languages. How do you create a package yourself that you can pip install in Python? All of these things you have to learn. And I think that those are kind of harder to learn because they're just, in the industry, it's just taken for granted that you know how to do that. So from that point of view, I think with any programming language, learn just the language itself. In a way, that's the easy part, because we're all smart, you know, we all can learn a for loop and practice it. But learn the tools, and I think a great way to learn the tools is create your own project. Like I created my website in Python, and if you go to my website, there's actually a part that says how I created this website. And it tells you all the tools that I used. And a big reason I did that was just to practice Python and to practice, you know, Git, and to practice all of this stuff. So I think that that is the second half of learning any language.
Great. So what made you take the decision of moving from mathematics to the field of AI?
Okay, that's a great question. I mentioned in my presentation that I studied. I mentioned in my presentation that I studied infinite-sized matrices, and I was also very good at calculus. And this was like, I graduated in 2013, so this is before like AI was a big deal. It wasn't even on the news or anything. And then a few years later, I heard about AI, but I didn't know it had anything to do with math. And when I started doing Andrein's course, he started talking about, well, you multiply matrices together. I had 100% in linear algebra. So I was like, wow, this requires like linear algebra and matrices. That's down my alley, you know, calculus. So for that reason, because when I graduated math, I was actually kind of upset that I wouldn't use these skills in the real world because I was so good at them. And the fact that there's a field out there that uses those skills, but also is very high in demand and has high salaries, to me, that's like the perfect opportunity. So that's really the main reason. And for that reason, that's why I like to emphasize that, you know, it's important to know the math, because if you know the math, it's hard not to kind of look down on someone who just like thinks of a neural network as you just press a button, you train some stuff, and like there is so much beauty behind how that happens. That's really cool. That you, in order to do that, you have to know like exactly how partial derivatives work and things like that.
Great. So you also mentioned in your presentation that you should also consider other algorithms than deep learning. Can we like discuss this more? Like, I think deep learning has solved many problems in the last few years, and it's coming like it became the state-of-the-art approach to many machine learning problems. So do you think other approaches like really worth studying or taking much time learning?
Something you will notice in industry is that people are going to look down on neural networks for the fact that they're not explainable. And this is a big deal in companies, because if a company wants to make a prediction, they want to be able to, like, you know, if they ever get sued, they want to be able to go in front of a court and explain, here's the algorithm we used and here's why the algorithm predicted it. And because neural networks don't have that capability, some companies will just not be able to use it. So you want to understand that, like, for that reason, there's going to be some company who is excited about neural networks, but when you get in there, they're going to say yes, but we can't use it, unfortunately, for this reason. So this is just a preamble to say that you're not always going to get what you want. You're not always going to get to, like, use deep learning if that's what you want to do. But as far as learning all those other ones, the thing is that I think a lot of those other algorithms are a little bit easier to learn. And I personally don't, I've used a little bit of each. Like I used, you know, you should, like, know how to use logistic regression. You should know how to use decision trees. Another one is like XGBoost. That's the most popular one for Kaggle competitions. And if you just do like a small project where you train something once and walk away from it, you don't have to memorize it after that. Just know that because you've done it once, you can always go back to your notes to refresh your memory on how it works. But I do think that it's important to be a little bit well-rounded in this field.
Yeah, to have like
but not necessarily be an expert. Like pick maybe, because for me, like deep learning, that's my expertise, but the other ones I just know of them, but I'm not interested enough to be really, really good at them.
Yeah, so it's good to just know the basics and maybe like apply them like in a simple manner. Great.
Yes.
So we have a question. How do we start learning these tools? I think
which tools exactly?
That question is from Noor. I think he means the Kubernetes and these tools you mentioned when you were talking about Python.
Yes. How do we start with learning those tools? To be honest with you, the hardest part is knowing which tools to learn. And this is why what I mentioned in my slides, where I said learn cloud and things like that. If you just start reading about the cloud, that's going to help you a lot. Kubernetes, Docker, all of these tools. There's a, let me see if I can find this. There's a book called Designing Data Intensive Applications by O'Reilly. Designing Data Intensive Applications. O'Reilly is the publisher. Like this book right here, it might not be something you want to read now, but that book will like explain to you, here's what happens in the real world. You build a big system that has consistency, scalability, reliability, efficiency, data stores, like that's the kind of level where you're just like learning all of these tools like Kubernetes. But at the end of the day, I would say Kubernetes and Docker, you're going to have to use them eventually. So you might as well start learning them. As far as like stuff in this book, which I haven't even gotten to, like once you have all of those skills, they're going to get into the level of like, how do we design a system where, you know, we can reduce the latency and all of that, all of those kinds of questions, like assume you know those basic tools. But yeah, learn the cloud, learn AWS. I personally prefer these books called For Dummies. You guys know those books? They're like yellow. So like I read a book called Cloud Computing for Dummies, and those books are really, really good because they explain things to you in a very basic level with using like easy language. So that book introduced me like, what is the cloud? How does it work? Why the trend? A lot of things in software, you have to know the history of why those systems exist. So for example, like before the cloud was a thing, like 15 years ago, people used to solve problems differently in software. And today they don't do it that way, but it's become better and better in some ways. But in order to understand why, because a lot of like you guys are young undergrads and you're just told to study Docker. But then somebody like I work with people at Microsoft who have 20 years of experience. They can explain to you why Docker came to be, because before Docker, people were doing things in a different way and they had all these problems. So Docker solved all these problems, and they can tell you all the headaches that they had to do 20 years ago. But I believe that even though I wasn't there back then either, I learned, oh, now I can appreciate why it's a tool that I should know how to use.
Awesome. So our last question today, it's kind of a cliche, but I want to know your opinions on TensorFlow versus PyTorch. I think this is a common question, but I would like to know like what your opinions on this.
I learned a little bit of both, and here's what I did was back when I started learning it, there was TensorFlow, there was PyTorch, and there were a bunch of other ones. There was like MXNet, and there was like a big list of them. And what I did was I just said, okay, well, TensorFlow and PyTorch seem to be at the top. And first of all, like, I don't think it's possible to learn all these things. So what I did was I just picked one. The one I picked was TensorFlow because I like Google. I like their documentation on TensorFlow. PyTorch was created by Facebook, and that was also good. And both are excellent products, but PyTorch is used a little bit more on research-based, and TensorFlow was used a lot more in production. At least that's what it was like about a year, 2 years ago. And the trends are always changing. So for me, like just pick one and just learn it. For me personally, I like TensorFlow a little bit better because I think from when I used PyTorch, you have to, TensorFlow allows you to have a level of abstraction where you can create a simple model with 3 lines of code, whereas with PyTorch, you always have to go under the hood a little bit more. And to me, like that simplicity is just really, really useful. Like there's a quote that I heard where make the simple things simple, but make the complicated things possible. And I think that TensorFlow allows you to do that. Was PyTorch just like starts with complicated.
Great. Thank you so much, Aleksandr, for your time and this great talk. I hope we can do this sometime again soon.
Thanks, thank you so much for having me. I really enjoyed talking, and thank you.
Thank you. Thanks everyone for attending. There will be a survey sent to your email after this session. Please fill it out and you will receive a 50% discount coupon on any of DeepLearning.ai's courses on Coursera. Hopefully it will help you. Thanks again, Aleksandr. We were very happy to have you with us today. And have a nice day.
Bye, everyone.
Have a nice day, everyone.